Solutions. Our definition for a solution: it is a homogeneous mixture in which one substance is uniformly dispersed in another. In this case, if I take, for example, something like sugar or salt, this is now the solute. I add water. The water is the solvent. And as you mix them so that you in the end have a homogeneous mixture, we can refer to this as a solution. Homogeneous, in other words, you cannot distinguish more than one phase, they become one. It's a uniform mixture that you get. And there we have our solution. Now there are different types of solutions. You can, for example, have gas dissolved in gas, like air, in which we have lots of nitrogen, which is this, we can say is the solvent, because 80% plus minus of the atmosphere is nitrogen, and then oxygen is one of the solutes that you have in the solution. Then it's a mixture of gas in gas. You can have even gas in liquid, like in soda drinks, where you have carbon dioxide dissolved in the solution of cold drink. We can have liquid dissolved in liquid, like in the case of vinegar, where the acid is dissolved in water. It's a more diluted mixture. So there's different types of solutions, and we need to remember it in that way. Now, when we discuss solutions further, it is important for us to distinguish between electrolytes and non-electrolytes. Now, what do we mean by an electrolyte? An electrolyte is a solution that can conduct electricity. And when will a solution be able to conduct electricity? Only if it contains ions that are free to move around. In other words, if we have ionic substances dissolved in water, the water particles will separate the ions in the ionic substances from each other, so that you have, say for example, I take table salt, sodium chloride, and I dissolve it in water. Then I'm going to end up with sodium ions and chloride ions, and they will be free to move around when they are dissolved in the water. And if you have these, you can, if you have a solution of sodium chloride, and you have those ions in the solution, it is possible that we can have electricity conducted by these ions. So if I now have a battery here, we can even say let's put a little light, a little bulb in there, and there you have your solution. Now if you have these ions there in the water solution, it is possible for the ions to move around, and then they can conduct electricity. So if you have a situation where you have ions in the solution and the ions are free to move, they will be able to conduct electricity. So the charges will move around and you are going to have the electric current flowing. The moment you have something that is causing lots of ions, you will refer to a substance like that as a strong electrolyte, because it will give you very good conduction of the current. A weaker electrolyte will only have a few ions, and of course a non-electrolyte is the moment we have particles where you don't have ions at all, but you have molecules. And molecules will not be able to conduct electricity. For example, pure water without any ions dissolved in the water will not be a conductor, so it will be a non-electrolyte. So what is an electrolyte? An electrolyte is a solution containing ions that can conduct electricity. Our strong acids, like, for example, hydrochloric acid, you know them very well. Hydrochloric acid, sulfuric acid, nitric acid. These acids are strong acids. And what is our definition for a strong acid? It is when you take that acid, you add it to water, and it completely ionizes. So you have lots of ions formed. The same with sulfuric acid, the same with nitric acid. So they are strong electrolytes. An acid like, for example, acetic acid. Now, acetic acid contains ethanoic acid. You know it better. The IUPAC name will be ethanoic acid. The 2 carbons that you have there. Now, ethanoic acid or acetic acid is a weak electrolyte, because when you add it to water, some of these will bond to the water and give you the hydronium ions, but many of the molecules will still stick together. So you are only going to have a partial ionization taking place. So there will be ions to conduct electricity, but it will not be lots of them. And therefore you cannot refer to this one then as a strong electrolyte, it will be a weak electrolyte. Strong electrolytes, things like the strong acids, strong bases, very soluble ionic salts will also be strong electrolytes. So a strong electrolyte is a solution containing lots of ions, where the ions can conduct electricity very well. A weak electrolyte, where you only have partial ionization, and then if you dissolve something like sugar in water, sugar is molecules. It's not going to give you ions in solution. So sugar will not be a conductor of electricity at all. And then you will refer to sugar as a non-electrolyte if you have a sugar solution. So that is as far as our electrolytes are concerned. Then we must also remember that whether your substances will dissolve or not depends on their nature. A polar substance now here we refer to substances like sodium chloride, for example, an ionic substance. They consist of positive and negative ions. A polar substance will dissolve very well in a polar solvent. Polar solvents, water is the most important one. And what is the reason behind that? We have to have a look at the intermolecular forces. In sodium chloride, you have ionic forces, which is very strong, electrostatic attraction between the positive, negative ions. In water, we have strong hydrogen bonds. So because here you have strong interaction and there you have strong interaction, you are going to have solution taking place. So polar substances will dissolve very well in polar solvents. Sodium chloride will not dissolve very well in something like, let me just write a few of them, the non-polar solvents: benzene, carbon tetrachloride, carbon disulfide, just to mention a few. Ether, they are the non-polar solvents. Now, a polar substance like sodium chloride will not dissolve very well in those. But if you take, on the other hand, something like gasoline, or oil, or butter, non-polar substances, we find that they dissolve very well in the non-polar solvents. but they will not dissolve in the polar solvents. And that is where we come to that saying of like dissolves like. So polar substances will dissolve, polar solvents will dissolve polar solutes, and non-polar solvents will dissolve non-polar solutes. Here, I didn't mention here what is the intermolecular forces, you know them. When we are dealing with the non-polar substances, it is just London forces you have between the molecules, and you will have it with a solute and you will have it with a solvent. That's why they mix. So in the case of the polar, you have strong forces, that's why they mix. In the case of the non-polar, you have the weaker intermolecular forces.